have a review of what we had in session 2. Last meeting, that was 2 Saturdays ago, we studied T-test, no? And then, what are the 3 types of T-test that we studied? Would you tell me what are those 3 types of T-test? Who knows? Remember when we studied T-test in our session 2? Oh, who remembers what are those 3 types of T-test?
Dependent, independent,
Correct. Yeah. First, we have the, as you mentioned, the dependent T-test. We have the independent T-test, and then the single sample T-test. Okay, let's take them one by one. Do you see my screen?
Opo, sir.
Yes, sir. Visible po.
Okay, so as I mentioned, there are 3 types of T-test. Number 1 is the single sample T-test. Like, for example, the national average for math score is 50. So we can compare the math score of our respondents to that national average of 50. That's an example of a single sample T-test. Okay. Next, there is this dependent sample T-test. No? The best example here is comparing a pre-test and a post-test. Or let us say, for example, we compare the math score versus the reading score. That's an example of dependent sample T-test. And then the last one would be the independent sample T-test. Like, for example, we want to know the difference in math score of males versus females. Okay, and as we mentioned, now you must take note that for this independent sample T-test, there must only be 2 categories. Now, for your categorical variable. Now, like in that case, the categorical variable is your gender. So we compare the math score of males versus the math score of females. Now, if for example, you are going to use a categorical variable with more than 2 categories, let us say, for example, the SES or the social economic status. Like, for example, you have the low SES, the middle SES, and then the high SES. In that case, the T-test will not be applicable. In that case, we are going to use the ANOVA or the analysis of variance. Okay, and that we will take up today. Okay, now to continue our review for the T-test. Okay, so last time, we compared the average writing score of those students that we sampled. Okay, the average writing score was 52.775. And then we compared it to the national average of 50. Okay, which is higher. There is a difference of 2.775. But as we studied last time, the question is there a significant difference? Okay, and we can answer that by looking at the p-value here. Now, if the p-value is less than 0.05, then we say that there is a significant difference. Okay, so here we said, in this example, the t-statistic is 4.1403 with 199 degrees of freedom. The corresponding two-tailed p-value is 0.0001, which is less than 0.05. Therefore, our conclusion is, the writing score is significantly different from the national average of 50. Okay, and then we say that a single sample t-test showed that the respondents had higher average writing score than the national average writing score. And then what are our disclosures? The p-value with the degree of freedom, okay, in parentheses, and then the p-value. The p-value is equals to 0.0001. And the readers would know that this is significant because the p-value is less than 0.05. Okay, and then we had another example. Okay, this is now the paired or the dependent t-test. What did we compare? We compared here the writing score and the reading score. We wanted to know if there is a significant difference between the writing score and the reading score of the participants. And what did we find out? Okay, we found out that the writing score was 52.775, and then the reading score was 52.23. So there was just a difference of 0.545. But we want to know if that difference of 0.545 is significant. So we look at the p-value. The p-value is 0.3868, meaning that it is greater than 0.05. Okay, so therefore it is not significant. And then how did we interpret that? It says here, an analysis of variance showed that the average writing score disclosed the mean, disclosed the standard deviation was higher than the average reading score. Disclose the mean, disclose the standard deviation, the p-value, and then the p-value. The p-value tells you that there is no significant difference. And then we go to the last example. The last example is the independent group t-test. Okay, and then what was our example last time? Okay, we compared the writing score by gender. No, I will explain later why I renamed this female, but this is gender. So we actually compared the writing score of males and the writing score of females. Now, what's the difference? The difference is actually 4.869947. But the question is there a significant difference? The p-value here is 0.0002. Now, meaning there is a significant difference. So, sino daw ang mas magaling? Mas magaling daw sa writing si female. At yung galing niya is significant, over males. And how did we interpret the results? It says here that an analysis of variance showed that the male students disclosed the mean, disclosed the standard deviation, had lower average writing score than the female students. The mean is equals to 54.99. Standard deviation is 8.13. Disclose the p-value with the degree of freedom, and then the p-value is equals to 0.0002, which is less than 0.05. Okay, so that is our review of the t-test. And I'd like you to remember that we apply t-tests, especially the independent sample t-tests, if we're looking for, if we have categorical variables with two categories only. So in the HSB2 file, what are those? Like, for example, you're comparing male versus female, public versus private students. Okay, now I proceed to ANOVA. Let me now share my screen.
Sir, question lang po.
Yes.
Sir, saan po nakikita yung, di ba dun sa analysis meron tayong T, tapos nakaparenthesis yung 198. Saan po nakuha yung 198 dito sa sir?
Okay. Let us share it again.
Degree of freedom po yan?
Yeah, the degree of freedom.
Yung degree of freedom po ba yung letter T, sir?
No. The degree of freedom is the number in the parentheses. Let's share it again.
Opo. Yung po yung nasa number sa parenthesis na po. Sige,
Yes.
salamat.
Okay. So no need to share it to show it. Okay, let's share the screen for ANOVA. ANOVA. Okay, today we're going to finish hanggang regression, no? Yung linear regression natin. So that we can move on to the next assignment already. Now we are introducing the one-way ANOVA. Okay, what is the meaning of ANOVA? It is one-way analysis of variance. And it is used to determine whether the mean of a dependent variable is the same in two or more unrelated independent groups. However, as I mentioned, it is typically used when you have three or more independent unrelated groups. Since an independent sample t-test is more commonly used when you just have two groups. Okay, so just to simplify that, no? When you do t-test, our example is that for gender, no, the math score of males and then the math score of females. Okay. Now, what about ANOVA? If you have three categories for social economic status, like for example, you have the low, the middle, and the high SES, you should use ANOVA. Like for example, I want to know the difference in the math score, no, of the low, the poor, or the middle income, or the rich. Now, in that case, I will use ANOVA. Okay, so next slide. So here there is an example. It says here, you can use a one-way ANOVA to determine whether exam performance differed based on test anxiety levels among students. Like your dependent variable would be exam performance measured from 0 to 100, and your independent variables would be test anxiety levels, which has three groups. What are those three groups? The low stress students, the medium stress students, and then the high stress students. So you want to know, okay, or you want to compare, the exam performance of these three groups. What are the three groups of students? The low stress students, the medium stress students, and then the high stress students. Okay? Another one. A one-way ANOVA could be used to understand whether there is a difference in salary based on degree type. So what could be those degree types? Let's say, for example, the business studies, psychology, biological sciences, engineering, and law. Okay, in our HSB2, are there other variables there where we can use ANOVA? Ano pa yung ibang categorical variables that we have in HSB2 where we can use ANOVA? Do you remember? Who remembers? Yung anong category si yung mayroong Asian, Hispanic, American? Is that the nationality? Anong pangalan nung variable na yon?
Nationality yata po.
Nationality. Di ba there were four? You can use ANOVA there. What else? Yung program. How many are there in the program? Di ba meron siyang vocational? Like for example, ours, no, in senior high school, we have different tracks. Okay. Ayan, there you can use ANOVA also, because there are more than two categories. Okay, I hope we are clear on this. Okay, next. Now there are certain assumptions, no, that we have to consider when we are doing ANOVA. So it says here there are 6 assumptions that underpin the one-way ANOVA. Okay, so let us have these assumptions. Okay, now your dependent variable should be measured at the continuous level. Oh, please remember, no, in our session 1, we categorized variables in general, no, into 2. These are the categorical variables. These are the non-numbers. And then we had the continuous variables, or these are the numbers. So here, if you have to do ANOVA, okay, the dependent variable is a continuous variable. Like for example, no, the math score, the science score, what else? Here, no, the exam performance. Other examples, no, height, measured in feet and inches, the salary, the intelligence, etc. The sales per month. Okay, so these are numbers. Like for example, no, you want to know the sales performance of males versus the sales performance of females, no? So yung sales performance, it's a continuous variable. Although we mentioned, no, kailangan we have 3 or more categories for the categorical variable. Okay? Now let us have assumption 2. Okay, your independent should consist of 2 or more categorical independent groups. Although we mentioned for ANOVA, okay, we are going to use 3 or more. Okay, another one, assumption number 3. You should have independence of observations. Now, what do we mean when we say independence of observations, which means that there is no relationship between the observations in each group or between the groups themselves. Like for example, no, one person belongs to the male category. He cannot belong to the female category. That is, one participant belongs to one category only. He cannot belong to the 2 categories. Okay? Next, there should be no significant outliers. Now, what would be an example, no, of outliers? An outlier is simply a single case within your data set that does not follow the usual pattern. Let's say, for example, no, the regular score, no, of the students would be 50, 51, 53, 60, and then one has a grade of 98. No, we call that an outlier. Okay, so let us have assumption number 5. It says here that there must be an assumption of normality. Okay, that we will take in another example, sorry, in another lesson. And then here, there needs to be homogeneity of variances. What do you mean when you say homogeneity of variances? Let's just admit one student. It says here the assumption of homogeneity of variance is an assumption of the independent sample Ttest and ANOVA, stating that all comparison groups have the same variance. How do we measure? No, that means the samples, no, in one group compared to the samples in another group. So sinasabi niya dito that each group sizes may be defined by the ratio of the largest to smallest group being less than 1.05. So the sample size, no, of the bigger group should not be greater than 1.5, no, of the sample size of the smallest group. That's how we determine the assumption of homogeneity of variances. Okay, next. Let us have here an example. I'll read the example. It says here, an online retailer wants to get the best from the employees, as well as improve their working experience. Currently, the employees in the retailer's order fulfillment center are not provided with any kind of entertainment while they work. However, the retailer wants to know whether providing music, which a few employees have requested, would lead to greater productivity, and if so, by how much. Therefore, the researcher recruited a random sample of 60 employees. The sample of 60 participants was randomly split into 3 independent groups. Okay, so would ANOVA be applicable here? Yes, because there will be 3 categories, no, of employees. And what are those 3 categories of employees? A, the control group that did not listen to music. B, the treatment group who listened to music but had no choice of what they listened to. And then 3, the third group, another treatment group who listened to music and had a choice of what they listened to. So there are 3 groups. Those who did not listen to music. Group 2 would be those who listened to music, no, but they didn't have to choose, no, which music to listen to. And then the third group would be those who listen to music, but they were given the opportunity to choose the music that they would listen to. Okay. So the experiment lasted for 1 month. At the end of the experiment, the productivity of the 3 groups was measured in terms of the average number of packages processed per hour. Okay, so this will be the continuous dependent variable. Therefore, the dependent variable was productivity. It says there. Okay, and then the productivity of each group was compared, no, against each other. So that is an application of the ANOVA. So it says here, a one-way ANOVA was used to determine whether there was a statistically significant difference in the productivity of those 3 independent groups. Okay, so now let us have an example using our Stata. How do we do that? No? Okay. So I'll open HSB2. As I mentioned, no, every now and then, for all our illustrations and demonstrations, now we are going to use the HSB2. I'll open my Stata. I'll share my screen. Okay, do you see now my Stata program? This is now the welcome screen for Stata. Do you see it?
Opo, sir.
Yes, thank you.
Yes,
Okay,
po, sir.
now I start. To start, okay, as we mentioned last time, we need a log, no, for all our state activities. So what we do is file, log, and then begin. Wait, Danica, it's just wait, log, sorry, file, log, begin. Okay, and then I will save the file name. Medyo mabagal lang. So I'll save it in session 3. This is now our Stata session 3. Okay? And remember, no, the extension is .smc. Yes, Danica, question?
Hey, sir.
Yes.
Medyo confused ako. Yung, di ba po, we are trying to study about Stata.
Yes.
Stata innovation to help us interpret yung si ANOVA po ay
Okay.
Ano din po ba ng pag-i-interpret natin o ano po ba? Medyo nalito po ako kasi na-integrate siya sa Stata natin ngayon, for example.
Yes, we will do ANOVA by using Stata. Just like what we did last time.
Okay, sir.
Before we demonstrated t-testing by using Stata. Okay. Now we will demonstrate ANOVA by using Stata.
So, meaning, sir, si ANOVA is also a way of interpretation.
No, it's a
ng
way
variables.
of computing. It's a way of computing. Yeah. The difference.
Tapos.
Okay, let's say, for example, we want to know the difference in math score, no, of students in different social-economic status. Stata will help us compute for that. And then, ours naman, the students and me, we will interpret the result. That was given to us by Stata. Okay?
Okay, sir. So, sa lahat po ng ano natin, sir, ang gagamitin natin is
statistical computations natin, we will do
Stata.
Okay.
Tapos, yung way po ng pag-interpret natin and pag ano dun sa magiging result ni Stata is ANOVA if 3 variables po yung i-interpret. Tama po ba?
No. I'm sorry. The statistical computation is the ANOVA.
Okay po.
The statistical computation is Ttest. Yung mga ganon. The statistical computation is the mean, the frequency table. So everything, correlation, regression, all of them will be performed by Stata. Okay. And then tayo naman, i-apply natin for our research. No? We are discussing how they apply to our quantitative research.
Okay, sir. Thank you po.
Clear?
Okay na po.
Yeah, if you are confused, it's okay not to ask questions. Okay? So this is just similar to what we did in session 2. But this time, we are demonstrating the ANOVA instead of the Ttest. Okay, and I will use the same HSB2, the demo file that we use also in session 2. Okay, so I will do file, open. Okay, again, I will open hsb2.dta. Okay, so do you see my screen now? The variables, okay, the data set has already been uploaded. Do you see this ID, female, race, SES, school type, program? Okay, female stands for gender. Okay, if I click data editor, do you see my spreadsheet?
Yes po.
All right. Okay.
Yes, sir.
Now, this female, I'll change first to gender, no? Okay. I just double click, okay, and then name, I'll just change it to gender. Okay, so I have this information. I have the gender of the students, which who I surveyed, the race. Yeah, this one. This is the one that I was asking a while ago. The Hispanic, the Asian. I think we have how many? Race, the African American, and then the white. No, and then we had the low, middle, and high SES. And then we have the school type, which is public or private, and then the program of study. It can be vocation. What else? Academic. There's the other one, general. I think there are 3 programs of study. And then we have the 5 scores. You have the reading score, the writing score, the math score, science score, and then the social studies score. All right. Okay, so next. Let us say, for example, no, I want to know the difference in math score, no, of students based on their SES. Okay, so this will be the command. So it's one way, I repeat. So I'll write one way, and then the math score, I'll just click it there, and then the SES, comma, and then we have here the T. Look here. Okay. Now, this is the result of the command, a one-way math SES T. Okay. Now, this is called an omnibus test. Why just an omnibus test? Because it just gives you the difference between groups, no? That is between groups, no? The low, the middle, and then the high. No, is there a significant difference in their what is that? In their math score? Okay. Now you look here, no, at the p value. If the p value is less than 0.05, therefore, okay, there is a significant difference between the groups. But no, you do not know if low versus middle or middle versus high or low versus high. So there must be a way, no, of determining that one. So in that case, let's try another command, no? Okay. So here we have your one way, then you have your math, SES, comma, T, and then you write BON. BON is short for Bonferroni. Okay. And the result gives you a comparison between the low and middle, the low and the high, and the middle and the high. So this time, no, I know that there is a difference between groups, and I know there is a difference between middle and low, the low and high, and then the middle and high. Okay, let's have a question. Okay, yes. Danica.
Sir, dun sa variable, saan po galing yung T? Tsaka, yung bond po, ibig po sabihin ay?
Okay. T is a command. No? T is a command. It's not a variable. Okay, these are the variables that you have. Diba? Here, you want to know, because sabi natin, one of the assumptions would be, we are determining the differences in a continuous variable. Now, like for example, I want to know if there is a difference in the math score of the poor, the middle income, and the rich. Now, I want to know kung sino pinakamagaling sa kanila sa math o mayroon bang pagkakaiba. Magkakaiba ba? This is your research, di ba? Your research is SES affects your math score. That's your framework. That's your hypothesis, di ba? SES affects your math score. So sinasabi niya, kapag poor ba, mababa ang kanyang math score? Kapag rich ba, mas mataas ba yung kanyang math score? That's more or less, no, that's your research. Okay? So yun ang variable. That's the dependent variable, the math score. Okay? Now, who are you comparing? No? Anong category? Yung SES, which has 3 categories: the low, the middle, and the high. Okay, question, what is T? No, T is a command, no, for the T value. Okay, and then BON, actually BON is short for the O4, no? the one who offered this test, itong post hoc analysis, you call this the post hoc analysis. Sorry for the terms, okay, is Bonferroni. No, so si Stata, ang ginamit niya yung Bon. This is short for the author. So this is how you do it. One way, okay, that's a command, the dependent variable, and then the categorical variable, comma, T, Bon. Okay, let's say for example, no, I want to know kung sino ang magaling sa reading score. Okay, so gagawin ko one way, read, SES, comma, T, Bon. Now, will I know, okay, if there is a difference between groups? Yes, no, okay. And, no, is there a significant difference if the p-value here is less than 0.05, like in this case, no, this is less than 0.05, then there is a significant difference between groups. But I want to perform a post hoc analysis using Bonferroni, okay, because I want to know the differences between groups. Like for example, no, in reading, I want to know, is there a significant difference in the reading score between the low SES students and the middle SES students? Kasi it shows here, the average reading score of the low SES students is 48.27. Okay. Now the average reading score of the middle SES students is 51.57. Sinong mas magaling sa reading? Okay, who's better? The middle SES students. But is there a significant difference? Now this second number here is the p-value of the comparison between low and middle. And this number is greater than 0.05. So you say that there is a difference of 3.30. Mas magaling si middle SES kay low by 3.30, but the difference is not significant. Okay, now I want to compare who is better in reading between the low SES students and the high SES students. No, it shows here that the high SES students has 56.5 score. The low SES students has 48.28 score. Therefore, there is a difference of 8.22. Now, is there a significant difference? Now, the p-value here is 0.0, which is less than 0.05. Therefore, there is a significant difference in the reading score of the low SES students versus the reading score of the high SES students. Now, my question is, what about the middle versus the high? Is there a significant difference in the reading score? Answer. Is there a significant difference? Yes, there is a significant difference because the p-value here is 0.009. Okay, so that's how we demonstrate ANOVA. Okay, you have to determine if there is a difference between groups. That's what we call an omnibus test. And then you have to determine, no, you have to compare, no, one group versus the other group. Where lies the difference? That's a post hoc analysis. And in the post hoc analysis, we used Bonferroni. Okay, so now we go to the interpretation. Now, how do we write? How do we write this? As I mentioned, Stata will assist us in determining or in computing, no, for the ANOVA, for the differences, and for the p-values. Now, now, when we write our research papers, now how do we interpret? Okay, so let me go back to my PowerPoint. No, I think this is math score. So let's compare first math. I'll do it again. So it says here, one-way math, SES, comma, T1. Okay, so this is the result. Okay, now I'll stop sharing this Stata. I'll now share my PowerPoint. Okay, so we are here. Do you see my PowerPoint? Do you see this?
Yes
Is,
po.
yeah, is it shared to you? Okay, so this is the command one-way math SES, comma, T bond. And this here, we have here the result. How do we interpret? Yeah, the interpretation is quite long. Okay, so for a while. This is the first interpretation. Okay. So it says here that an analysis of variance showed that the difference in math score among the different social economic status, or you can write among students from different social economic status, was significant. Okay, you have to disclose the F value and then the P value, which is 0.0005. Okay, now the next interpretation is this here. You have to indicate where lies the difference, and this is by using a post hoc analysis. When I say post hoc analysis, no, it means you have to compare one group from the other group. So it says here, the post hoc analysis using Bonferroni post hoc criterion for significance indicated that the difference in math score, first we compared the low SES and then the middle SES. Okay, what are your disclosures? You have to disclose the mean or the average. That means the low SES students had 49.17 math score with a standard deviation of 8.88. And then the middle SES students had 52.21 with a standard deviation of 9.36. Is it significant? It was not significant. The p-value is 0.184. Next, the next interpretation is the comparison between the low and the high. And as we mentioned, it was significant. The p-value is 0. So let us read it. The post hoc analysis using Bonferroni post hoc criterion for significance indicated that the difference in math score between the low and the high, okay, was significant. Why the p-value is less than 0.05. Okay, and then what are your disclosures? You have to disclose the average math score of the low, which was 49.17 with the standard deviation of 8.88. You have to disclose also the average math score of the high SES students, which was 56.17 with a standard deviation of 8.69. And then lastly, okay, you have to compare what? The middle versus the high SES students. So you say post hoc analysis using Bonferroni post hoc criterion for significance indicated that the difference in math score between the middle SES, okay, so that's 52.21 with a standard deviation of 9.36, and high social economic status, mean of 56.17 with a standard deviation of 8.69. Was it significant? Yes, it was significant because the p-value was 0.028. So that is how you interpret. Okay? So when do you do this? No, if that is your research, kapag yun ang framework, no, na ginagamit mo, no? Like for example, is there a significant difference? Like for example, no, sinasabi mo your independent variable is social economic status. Does it affect, no? Does it affect the math score of students? Yun ang framework, di ba? social economic status affects arrow the math score of students, and then you can do this this ANOVA. Okay, that's actually a framework for regression. Pero if you're doing Ttest or ANOVA, you can also identify your dependent and independent variables. So the arrows would be the same. Okay, now question before we proceed. Do you have questions?
None po.
So nakita niyo yung difference. May I ask, what's the difference now between a t-test, yung independent sample t-test natin, like for example, kanina, yung gender ng math score, at saka ito, SES math score. Anong pagkakaiba ng dalawa? Can you tell me? Anong pagkakaiba ng t-test na ginawa natin, yung when we just check the difference in math score of students based on gender, and then the other one based on SES. Where's the difference there?
Sir, yung variables po. Mas
Yung categories niya, Si gender has only 2 categories, and then yung SES has 3
categories
categories.
nga pa.
Okay. That is why in your survey, so in your assignment next meeting, you have to identify, you have to apply, i-apply nyo yung meron kayong 2, meron kayong variable na may 2 categories at saka variable na may 3 categories. That's why I asked you, when you conducted the survey, you include a variable that has more than 2 categories. Okay? But I saw that there are some students na kulang mayroong mga students na yung kanilang mga categorical variables, they only had 2 categories. So let's see what we can do for that. Okay? Yeah, Gilbert, that's correct. Where's Gilbert? Yung SES po has 3 categories.
Nasaan po, sir?
Okay. Now, I don't know. In business kasi, wala akong masyadong nakikitang research papers that uses Ttest at saka ANOVA. Pero kahit hindi ganun yung framework nila, other researchers naman, they show pa rin. Pinapakita nila. Like for example, ano ba yung dinemonstrate natin? Yung kay Maria, yung kay Fe. Nandito ba si Fe? Di ba you were checking the independence score of the respondents? Okay. When we can compare the independence score of males versus females, or let us say for example, sino bang mayroong 3 categories sa inyo? Anong variable ang ginamit niya? Let's say for example, religion, ano lang to, like Catholic, Iglesia ni Cristo, and then others. You want to know if there is a difference in the independence score of respondents based on religion. So if your categories are Catholic, Iglesia ni Cristo, and then others, okay, so ANOVA there applies. Okay? So if there are no more questions there, now I proceed. I proceed now to correlation. I'll now share my next screen. I'm sorry, next PowerPoint. Okay, now we're moving to correlation. In our introduction, we introduced correlation. Let's say, for example, we have two continuous variables. We have two numbers. Then we want to know if they go in the same direction. Like, for example, one is going up, the other variable is going up, or one variable is going down, the other variable is going down also. We say that is that a positive or a negative correlation? Is that a positive or a negative correlation when two variables go in the same direction? Answer. Is that a positive or a negative correlation? Yes, Michelle. Michelle. Yes, Michelle. Michelle, yes, you're raising your hand.
Hello po.
Yes,
Ayan.
Michelle.
Okay, it's a positive correlation, sir.
Yes. And what about a negative correlation, Michelle? How is that?
When they don't go to the same direction, let's say for
Yeah.
instance, the other one's a negative correlation and then the other one's a positive.
Yeah,
Correct.
like for example, Michelle, one is going up, the other
Up,
variable is
going down. Opo.
There is a negative correlation. No, and then we mentioned also last time, no, that if they perfectly go together, no, that's a correlation coefficient of 1. No, that's a perfect correlation. Pero pag sobrang sabog, no, yung no correlation at all, that's zero correlation coefficient. There is no correlation. Okay. So we said also last time, no, that correlation is different from regression. No, because in a correlation, we study relationships. No, we're not saying that one variable causes the other. Like variable 1 causes variable 2, we do not know. Or variable 2 causes variable 1, we do not know. Unlike, no, in a regression, it is the study of cause and effect. It is the study of causality. That means you have one variable, it could be one variable causing the other variable. That's why we have what we call the independent, no, the IV, the independent variable, and then the other one, the result or the outcome variable would be the dependent variable. And most of the quantitative research papers are more on regression. Now we have independent variables. Kasi normally hindi siya nakalimit sa one independent variable. You can have 2, 3, 4 independent variables. And then meron siyang dependent variable. Okay? Now, let us study in detail, no, what correlation is. Okay, so do you see my screen or my PowerPoint on correlation?
Yes po, sir.
Okay, so it says here, no, the person-product moment correlation, or short for person correlation, okay, or short, no, in short, person's correlation. It is a measure of the strength and direction of the association that exists between the two continuous variables. So remember, no, when we're doing correlation, we are comparing numbers. No, we are comparing continuous variables. That's why when we started, no, we made it very clear which variables are continuous and which variables are categorical. So again, I repeat, in a correlation, okay, you compare, no, you determine the association or the relationship, no, between two or more continuous variables. And now the correlation coefficient is called the R. I repeat, the R is the correlation coefficient. A person's correlation attempts to draw a line of best fit through the data of two variables. And the person correlation coefficient, the R, indicates how far away all these data points are to this line of best fit. Okay? And a perfect correlation is 1. That's a perfect positive correlation. A perfect negative correlation is -1. And when there is no correlation, the R is 0 or a value that is near to 0. Okay, so let us have one application of the Pearson's correlation. It says here, you could use a Pearson's correlation to understand whether there is an association between exam performance and time spent revising. No? When you say time spent revising, I guess this is the time spent for reviewing. Okay, like for example, no, you want to know if there is a correlation between your exam score and the number of hours, no, that you spend reviewing. Like your two variables would be the exam performance and then the review time measured in hours. If there was a moderate positive association, we could say that the more time spent revising was associated with better exam performance. No, so be very careful. As we mentioned, this is not regression. This is not cause and effect. So let me just make clear, no, that the number of hours you spend, no, for reviewing, no, does not affect, no, hindi niya sinasabing ganon. So we're very clear on that. So we're just saying here that there is a positive association between the two variables. Now there is just a relationship. I repeat, there is just a relationship. We're not saying that one, the review time, is causing the exam performance. No, we're not yet saying that. No, because we are still in the correlation. We're just saying that there is an association. In this case, it's a positive association. Okay? So next. You could use another example, a Pearson's correlation to understand whether there is an association between, this is the length of unemployment and happiness. No? And I guess here it says that there was a strong negative association. That is the number of, or the length of time, no, that you are, or the person is unemployed. That length of time is negatively associated with the happiness level of that person. Again, we are just stating that there is a negative association. We're not saying, no, that variable 1 is causing variable 2, because in that case, that will not be correlation anymore. That will be regression. Okay? Now, let us have some of the assumptions that we have in correlation. Okay. So number 1 assumption is we are correlating numbers. No, we are correlating continuous variables. So we don't correlate gender and social economic status. You don't do that. No. Okay, in the HSB2, no, example, what can we correlate there? What can we correlate in the HSB2 example?
Pwede po ba yung age, sir?
Yes, age. You can correlate age. Or in the HSB2, Chris Mark, what can you correlate there? What are the numbers there, Chris Mark?
Yung number of years po service, pwede rin po ba yun?
Yes, okay, you can correlate. Ano pa? Yung sa example natin sa HSB2, the one conducted for students. Anong variables ba doon ang pwede mong i-correlate, Chris Mark?
Yung score po nung
Correct.
sana, sir.
Okay. Di ba you can correlate math score, reading score,
Yes
science
po.
score, writing score. These are the things that you can correlate. Did you get that? No? Okay. So sinasabi natin, let's say for example, there is a correlation between the reading score and the math score. No? There is an association. There is a positive association between the two variables, so the reading and the math score. But we're not saying, no, that the reading score results to or affects, predicts, no, the math score. We're just saying that there is an association, or it could be a positive or a negative correlation. Okay, thank you, Chris Mark. Okay, number 2, there needs to be a linear, no, relationship between the two variables. Okay. And how is it linear? Ito yun. So, a scatter plot, okay, can show us if there is a linear relationship. Like in this case, no? Okay. So ito, there is a positive correlation. Parang most of the data are going up, then negative correlation, they both go, or some are going up, others are going down. Okay? And then this one, see kalat, no? There is no correlation. Of course, it will be different, no? It will be difficult to interpret the scatter plot here. That's why we have a Stata. Okay, let's have the numbers, no? We will know what's the correlation coefficient. Let Stata do that for us. Okay? Again, it says here that there must not be significant outliers. So yung mga medyo malayo, no? Like for example, here. This is an example of a significant outlier. Somebody's raising her hand. Sino yun? Michelle, yes.
Ay, sorry po na pindot. Di lang po na lower hand.
Okay, it says here, outliers are simply single data points within your data that do not follow the usual pattern. Example, in a study of 100 students' IQ scores where the mean score was 108 with only a small variation between students. Oh, one student has an IQ of 156. Okay, now let's look at the scatter plot. Okay, if you plot that, no, nandito si 156. Diba? So medyo kalat. The correlation coefficient is mababa, 0.40. But if you remove the outlier, no, nararagdagan yung ating correlation coefficient. It is 0.70. So it's higher. Okay? Next. Okay, there must be an assumption of normality that we will do next time. Okay. So let's have this example. Studies show that exercising can help prevent heart disease. Within reasonable limits, the more you exercise, the less risk you have of suffering from heart disease. One way in which exercise reduces your risk of suffering from heart disease is by reducing a fat in your blood called cholesterol. Yes, let's have a question from Danica. Yes, Danica.
Hi, sir. Sir, question lang po. Since di ba sa Stata, mayroon po mga command na medyo unfamiliar po sa amin.
Yeah,
Is it possible po na magkaroon ng legend, sir, para meron po
Yes.
kaming pattern?
Yeah, that I forgot, no? I promised to do that. Sige. Paki-remind na lang ako, ha?
Okay, sir. Thank you po.
Next. Sige, Julius, you remind me. Okay, Danica, no? Pwede mo akong i-remind. Tapos pagsamasamahin natin.
Opo.
Magmula
Yes po, sir.
Dun sa SAM, TAB, Ttest, ANOVA. Now we will be doing this one. This is correlation. So to continue, it says here, one way in which exercise reduces your risk of suffering from heart disease is by reducing a fat in your blood called the cholesterol. And then the more you exercise, the lower your cholesterol concentration. Furthermore, it has recently been shown that the amount of time you spend watching TV might be a good predictor of heart disease. No, like that is, the more TV you watch, the greater your risk of heart disease. Okay. So therefore, okay, what do we do? A researcher decided to determine if cholesterol concentration was related. Again, since we are just in correlation, no, we're just talking here of the relationship. No? Was related to time spent watching TV in otherwise healthy 45 to 65-year-old men. For example, as people spent more time watching TV, did their cholesterol concentration also increase? So it's a positive relationship, or did the opposite happen? No? Okay. So to carry out the analysis, the researcher recruited 100 healthy male participants between the ages of 45 and 65. And then the amount of time spent watching TV, that's a continuous variable. And cholesterol concentration were recorded for all 100 participants. Okay? So, anong lumabas? Oh, this is just the command, no? Okay, we will demonstrate that later. Let's look at the result. Ayan. Okay. So sinasabi niya, using our example where one variable is cholesterol and the other variable is time t, the required code would be one of the following. We'll do this, no? We'll do this using our own example. And ano yung naging result niya? Okay. Let's go to the result. Ito na yung output niya. Okay. Now, the output contains three important pieces of information. The first one is the R. The R is the correlation coefficient. The next number is the p-value, which must be less than 0.05. And then the third number is the sample size or the number of observations. For us, we will use number 1, the R, because we have to know the strength of the correlation. And the number 2, if the correlation is significant. And it is significant if the number here is less than 0.05. Okay, so let's look here. Ayan. So the first number is the correlation coefficient. Ito yun, ha? We're comparing time TV and then cholesterol. Okay, look at the table. Here kasi the first one is cholesterol versus cholesterol. So this is just one variable. And of course, this is a perfect correlation kasi this is just one variable. Or you cannot compare time TV versus time TV. This is just one variable. So saan nagkaroon talaga ng comparison dito? Sa cholesterol versus time TV. And the correlation coefficient or the R is 0.3709. Later, we will do an interpretation of the strength of the correlation. The next number is the p-value. Is it less than 0.05? Yes, this is 0.0001. It's less than 0.05. No? Therefore, no, the relationship between the two is significant. And then the third number is the number of respondents or the number of samples. Okay? So let's have some more. Let's have our example. Ayan. Ito muna. How do you interpret? It says here, a person's product moment correlation or a person's correlation was run to assess the relationship between cholesterol concentration and daily time spent watching TV in 100 males aged 45 to 65 years. Anong result? There was a moderate positive correlation between the daily time spent watching TV and cholesterol concentration. Okay, if the number is a positive, like in this case, 0.371, you call it a positive correlation. If the number is a negative, no, you call it a negative correlation. And P is less than 0.05. Or P is equals to whatever is the value there, with time spent watching TV explaining 14% of the variation in cholesterol concentration. Okay, so there was a moderate positive correlation between daily time spent watching TV and cholesterol concentration. R is equals to 0.371, P is less than 0.05. Now, this is more simple, no? Interpretation. Let's look at here. Now, sabi ko kanina, if the R is a positive, you call it a positive correlation. Okay? If R is a negative number, you call it a negative correlation. Saan ko galing si moderate? Here. Saan ko galing si moderate? So, this will be our guide. No? This is the rule of thumb for interpreting the size of the correlation coefficient. If it is between 0.90 to 1, now between 0.90 to 1, there is a very high correlation. So if it's positive, you call it very high positive correlation. If the number is negative, you say very high negative correlation. Okay, so if the number is between 0.70, you just make it this 0.89, no? Okay. 0.970 to 0.89, it's a high positive correlation for a positive R or a high negative correlation for a negative R. Okay, ito naman. 0.50 to 0.69. Okay, moderate, positive, or negative correlation. 0.30 no, to 0.49. It's a low positive or a low negative correlation. And then 0 to 0.29, it's little, if any, correlation. So balikan natin yung kanina, no? Okay. R is 0.371. So nandito siya, no? 0.371. So dapat low positive, no? Kasi 0.371, no? So hindi siya moderate, no? Dapat low positive correlation. Ito. Palitan natin, no? It's a low positive correlation. Okay, now let's have an example. Now, how do you compute, how do you do correlation? Okay, using Stata. This will be the command. I hope you see it. Medyo maliit lang siya. Tapian natin.
Loading ko po, sir.
Okay, so this will be the command, no? PW core, and then the variables that you are correlating. Like in this case, we will correlate the read and the write, comma, okay, sig star in parenthesis 0.05. Now let's do this, no, using our HSB2, using our Stata. Now, let's correlate read score and writing score. Okay, it shows here, no, that the R, or the correlation coefficient, is 0.5968. Okay, nasaan si 0.5968 dito? Asan dito si 0.5968? So is it very high? Is it high, moderate, low, or little? Asan dito si 0.59? Where's 0.59 there?
Moderate po, sir. Moderate po.
Yes, moderate. So we say that there was a moderate positive correlation between the reading score and the writing score. Okay, what's the R value? The correlation coefficient is 0.5968. Now, what is the P value? The P value is 0.0. Is it significant? Yes, it is significant because P is less than 0.05. Or you can write P is equals to 0, or you can write P is less than 0.05. Okay, so can we do that using Stata? I'll now share my screen for Stata. Okay, as we mentioned, the continuous variables here are the reading score, the writing score, the math score, the science score, and the social studies score. Okay, so here it is. Now it is PW core. That's a command. Okay, I'll compare read and write. Okay, and then comma sig star 0.05. Ayan. Okay. So that is the command. I repeat, PW core read write comma sig star 0.05. Okay, and then that gives you this result. No, the R coefficient, or the correlation coefficient, is 0.5968, and no, in the table 0.5968 positive is a moderate positive relationship, and the P value is 0.0. Okay, now can we do a correlation of PW core? Right and math. Ayan, sig star. And then this is 0.05. Okay. So, what is this? 0.6174. Saan siya nagpo-fall? Tignan natin. Yung 0.6174, okay, is another moderate positive correlation. Okay? So, balik tayo. Now, question, what if I want to know if there is a correlation, no, on all these variables, no, on all these continuous variables. Like in this case, PW core, kukunin ko sila lahat. Si read, si write, si math, science, and social studies. Pwede. Pwede bang yon? Yes, pwede. Star 0.05. Okay, and that gives me the correlation coefficients. But you just have to choose. No, like for example, no, read and read. No, don't get that. No, because this is just one variable. That's why it gives you a perfect correlation. But what will you get here? The read and write. So this is the correlation of next. Read and science.
Science.
Write and science.
Science.
Dalawang beses ko bang napindot si science? Ayun, dalawa pala siya. Ulitin natin. PW core. Ulit. Si read, si write, si math, science, and social studies. Sig star 0.05. Ayun siya. No? So, you can continue read versus, read and its association with social studies, write and its association with social studies, math and social studies, and then science and social studies. So you can do that. O question, no? In your, dun sa survey na ginawa ninyo, ano yung pwedeng correlation na pwedeng gawin nyo doon? Di ba you ask for the age? Di ba? You ask for the age. At saka yung independence score. Can you correlate? Yes, we can correlate. Although, inuulit-ulit ko, no? Yung result or yung score ng Likert, that is not actually a continuous variable. No? Although for us, there's ambiguity, no, on the treatment of variables, we treat them as numbers. So, kahit ordinal variables sila, ginagamit natin sila as continuous variables. So, question, sir, pwede ko bang i-correlate yung age at saka yung kanyang independence score? Pwede, you can do that. They are both numbers. Okay? Meron ba nagtatanong kanina? Do you have questions?
None po.
None. Okay. So that is a correlation. Now, maybe, no, if you have written a research paper, eto nakikita nyo na to, di ba? The relationship between, di ba may mga ganito na, di ba? May mga ganito na investigating the relationship between variable 1 and variable 2. Meron ng mga research na maganito, yung mga relationships, no? Pero medyo mababa lang siya kasi you're just checking on the association or the relationship. You don't really know which one is causing the other. No, like for example, meron siyang relationship, like in this case, ano ba yung mataas? Si reading at saka si social studies, no? Ang kanyang correlation coefficient is 0.6215. But I am not saying, no, na kapag magaling siya sa reading, no, nape-predict niya na magaling siya sa social studies. I'm not saying that, no. I'm just saying that there is a high association or relationship. Kasi pwedeng sabihin mong magaling siya sa social studies kaya magaling siya sa reading. Or, no, there could be a third variable or a fourth variable, no, na pwedeng wala dyan, pero nagkakaroon siya ng cause and effect. Okay? So that is now the lesson on correlation. I'm trying to finish hanggang regression, no? Because for the long Christmas vacation, I want you to look for a paper, no, that has relationship or regression, no, that we can do a survey following that paper. That will be your final paper, no? So I'll try to finish regression today. So para alam mo na kung hahanapin mo final paper.
Sige na, mag-ano kayo dyan.
Okay, no questions. So we have finished Ttesting. We have finished ANOVA. Now, we have finished also correlation. Now I'll go to regression. We cannot finish pa yung logistic regression, tapos yung moderating at saka mediating. No, we'll do that next year. Pero kung may makita kang paper na gano'n, na may mediating or moderating, you can get that paper also. But for the moderating and the mediating, we will not use Stata anymore. We'll use another software. We'll use Smart PLS for those. Medyo complex na kasi yung pagko-compute doon. Guys, I'll send you these files, no? Okay. Other offers, pwedeng iba yung terms na ginagamit nila, no? Pero ito, this one is acceptable. So even if when I'm giving exams, kasama to no sa examination paper para meron kayong kodigo how to interpret these numbers. Very high, high, moderate, low, at saka little if any correlation. Okay, so far, so no more, no questions pa. I'll share my now we go to regression. What's regression again? How is it different? How is regression different from correlation? A very simple way of differentiating them. Correlation is what? The study of relationships. What about regression? This is the study of what? Maria Jesusa Manalo.
If meron po siyang cause and effect to one
Correct.
another.
Yes, it's the study of cause and effect. The study of causality. Correct. Okay. So, Jesusa, can you think of a research paper that uses regression? Anong framework ang pwede mong ibigay? For example, the effect of what?
Kunwari po, the effect of distance learning dun po sa performance po ng bata sa school.
Correct. No? That is, yung performance niya, you have to measure it, di ba? Like for example, paano mo siyang measure? Let's say for example, yung exam score niya, no? That will be your dependent continuous variable. No? Pero yung distance learning ngayon, kailangan meron kang instrument, no, to measure distance learning. Pero tama yung sinabi niya. Now, the effect of distance learning on the examination performance of students. Ayan, these are the terms that we use kasi sa MAED, no? I'm sorry, pag ako kasi nagbigay ng example more on business, like for example, no, the effect of empowerment on the organizational commitment. Sabihin natin, applied to to teachers. Let's say for example, the effect of compensation on the job satisfaction, of teachers. So that's an example of a regression. Okay? What's another example? Yung sa field ninyo, sa MAED. Mayroon ako narinig dati, yung mother tongue instruction. Meron ba ganon?
Meron sir, kaso elementary po usually ang kasi foundation po nila yung
diba the effect of using mother tongue instruction on the academic performance of students. Di ba pwede? Tapos meron din yung parang we were using parang ano ba yan, visuals ba yon yung kapag nagtuturo kayo yung sa mga estudyante, yung I don't know what term they're using for teachers in elementary. Ano yon?
Multi-intelligence, sir? Intelligence? Ano po ba?
I don't know. Ano yung way of teaching ninyo, di ba, sa mga students? Kasi I've seen some Di ba may mga sila di ba may mga di ba sa public school may mga estudyante ako nagsusolicit sila ng yung mga widescreen na TV.
Apo, multimedia po sir.
Ayan, multimedia. Alam ko, no? Mga nagsusolicit.
Solicit pala, sir.
Bakit nagsusolicit? Wala bang ano doon? Walang budget for those?
O sa
Project
private
ma'am,
school,
sir, PTA, PTA.
Yeah, o sa mga ano po, sa mga private school po, sir.
Oo. Ganun na. Kung minsan ano, they solicit for trash can, di ba?
Opo.
O kaya meron. Yung kapag ano, what do you call it kapag umpisa ng klase?
Brigada eskwela po, sir.
Yeah, Brigada Square. I know. I
Marami po
remember.
donation doon.
Dami nga. Madali na kasi ngayon eh. Gcash na lang.
Tama
Alright.
po.
Send ko na ba Gcash pa, sir?
Okay, may mga utang po doon sa Gcash ni Ma'am Michelle.
Bugbog na bugbog na. Okay. So let's have linear regression. Okay.
Ito po mga ninong, sir. May mga ninong effect niyan para sa ano, epekto niyan sa Christmas na to. Matatago
Ano, sige,
na.
ano yung independent variable?
Matatago na
Effect anong effect ng alin?
Sir, question po.
Yes, sige.
So, dito sa regression, sir, parang ang research mo para siyang experimental, no, sir? Kasi pwede kang gumawa ng experimental research dito kasi gumagamit ka ng isang tool para makita mo kung effective siya or hindi. Pwede po siyang ganon?
I will not say exactly na experimental, pero nape-predict mo siya. Yung
Okay.
meron siyang predictive value. Yon. Like for example, high school math, halimbawa, kung magaling ka ba sa high school math, mape-predict ko. 'Di ba? Na magaling ako sa college math, parang ganoon.
So,
Kasi di ba
pwede
kapag experimental, ano siya, yung meron kang pre-test, meron kang post-test. Di ba? Iba naman yun. Parang, I would relate si experimental more dun sa t-test. Dun sa dependent sample t-test. Doon ko siya mas marerelate. Here we are predicting eh. Like for example, kami, applied in business. No? If I do this in the advertising, bibili ba yung customer? Diba? Nape-predict namin kung bibili or hindi bibili yung customer. O kaya for example, no, in business, meron kaming data for example dun sa mga nabebentang mga bahay. Like may bahay na 4 bedroom, meron siyang garahe, meron siyang ilang CR. Tapos when you have this tapos nape-predict mo kung magkano bebenta yung bahay through regression. So not exactly experimental. I would go more on the predictive nature of this regression. O question pa. Guys, pag isusulat niyo yung thesis niyo, regression is your friend. I tell you. After this, we'll demonstrate some research papers. Tapos kayo rin maghahanap kayo. Now let's share them in class. Okay, so let me now proceed with this. It says here that linear regression, also known as the simple linear regression. Okay, sabi natin kanina, meron kang independent variable, tapos meron kang dependent variable. Independent variable is the cause. The dependent variable is your effect. Okay, when you have one IV and one DV, yun ang tinatawag na linear regression. I repeat, kapag isang IV, the independent variable, isang DV, the dependent variable, ang tawag doon linear regression or simple linear regression. So for example, you could use linear regression to understand whether exam performance can be predicted based on review time. The dependent variable would be the exam score, and the independent variable is the review time, measured in hours. Okay, anong klaseng linear regression to? Pareho silang continuous variable. No, the independent variable is a continuous variable. What is it? The number of hours for your review. And then the dependent variable is a continuous variable. What is it? The exam score. Okay, so to proceed. An example, you could use linear regression to understand whether cigarette consumption can be predicted based on smoking duration. Like your DV would be the cigarette consumption, measured in the number of cigarettes, and then your independent variable would be smoking duration. So let's say, for example, 1 year ka na raw nag-smoke. So kaya ba natin i-predict kung ilan na yung nauubos mo per day? Or 2 years ka nang nag-smoke, kaya ba natin i-predict no, kung ilan ang nauubos niya per day? Did you get that? Okay, so another thing for regression is, what if no, you have 2 or more independent variables? Kapag yung IV mo no, naging dalawa na, no, ang tawag doon multiple regression. Alternatively, if you just wish to establish, oh well, this is going back to correlation. No, let's not have this. No, let's just have this: a simple regression and a multiple regression. I'll give an example of a multiple regression. Okay, just say for example, your research is investigating the effects of age and mother tongue instruction on the academic performance of students. So in that case, dalawa yung independent variable mo, yung age at saka mother tongue instruction. So that is an example of a multiple regression. But we'll start first with linear regression. Okay. Now there's a note here. We defined already the variables when we started. What's another name for dependent variable? It is also called the outcome variable, the effect, no? The target or the criterion variable. While the independent variable, ito yung cause, you can call it the predictor variable or the explanatory variable or the regressor variable. Ultimately, whichever term you use, it is best to be consistent. We will refer to them here no, as the dependent or the DV. Most of the time, I'll refer to them as the DV, and independent variables or the IV. Okay, let's have some assumptions. Okay, just like in the correlation, we had certain assumptions. Let's have some assumptions here. Okay, your dependent variable should be measured at the continuous level. Okay, so what we're studying here is a dependent variable, no, that is a number. Did you get that? No, your dependent variable should be measured at the continuous level. So our dependent variable is a number. Okay. Eh sir, pwede ba yung yung research, no, na yung dependent variable mo hindi number? Pwede. No, ang tawag naman doon logistic regression. Let's say for example, no, my research is the effect of parental role models, no, the effect of parental role models on the decision of the children to become entrepreneurs. O i-apply natin sa inyo. The effect of parental role models on the decision of the children to become teachers. Kapag teacher ba yung nanay o yung tatay or both, most probably ba yung anak magiging teacher din? Ayan, it's one. Oh. Ano yung dependent variable doon? The children the child becomes a teacher or doesn't become a teacher? Yes or no? Diba? That's an example of a logistic regression where the effect is not a number. Diba? Sinasabi mo, kapag teacher ba yung nanay or yung tatay or both, nagiging teacher din ba yung anak? Diba? Mayroon bang effect yung parental role model? Ayan. So that's an example of a logistic regression. Here for our lesson, no, we're just here. No, the dependent variable is still a number. Okay, so ano yung examples of this? Yung examination score. Ano yun? Parang may gumagawa ng suman. Ayan, examples of such continuous variables include height, temperature, salary, review time, intelligence, reaction time, test performance, and sales. Okay? Next, let's have assumption number 2. What about your causes, no? Or the independent variables? They should be measured. They can be measured at a continuous or categorical level. At this level, no, we can use a categorical, no, or we can use a continuous variable. Like for example, no, I want to know kung merong effect yung gender at saka yung age, no? Doon sa academic performance of students in Pulong Masle Public School. Ayan. So, investigating the effects of gender and age of students on the academic performance of these students. O, dalawa, no? Pwede siyang continuous, pwede siyang categorical. O kung isa lang, let's say for example, the effect of age. Or let's make a categorical, the effect of gender, ayan, on the academic performance of students. Or the effect of social economic status on the academic performance of students. Di ba mayroong ganon? May nakita pa akong isang research paper eh. Sinasabi niya kung kung OFW yung one of the parents or both of the parents, nakaka-affect din daw sa academic performance ng students.
Opo, sir.
Merong ganon.
Opo, sir.
Tapos supported by academic literature, di ba? So, paano siya, Julie? Sino ba to? Si Pampanga Council.
Ako po yun, sir.
Julius. Why Pampanga Council?
Tatawag po, sir. Hindi ko na rename kanina. Sana po yun, sir, sa Boy Scout po.
O yan. So, paano ba, Julius? Ano yung sinasabi ng literature doon? Mas tumataas ba yung kanyang academic performance o bumababa yung kanyang academic performance?
Ano po, sir, bumababa po kasi minsan nakaka-apekto po yung wala yung magulang mo sa bahay, wala po nag-ano sa'yo, nag-guide.
Diba? At saka nakasulat na yan sa literature, diba?
Yes po, sir.
Okay, next. Ito. There needs to be a linear relationship between the dependent and independent variables. Kaya nga sinasabi nila minsan di ba? Sabi nila, you check first kung papasa siya sa correlation before you do a regression. Have you heard of that? Yung mga research teachers natin. Sinasabi nila, before we do regression, let's try doing a correlation first. Kasi sinasabi niya, pag walang linear relationship, most probably, hindi rin siya magre-regress. Okay? Next. Ayan. Again, just like in correlation, there should be no significant outliers. And then number 5 here, the independence of observations. Ayan. We mentioned this already kanina. Na sinasabi natin, one respondent cannot belong to the two groups. If you belong to the male group, nandun ka. Or you belong to the female group, nandun ka. Or if you belong to the low, wala ka sa middle, wala ka sa high. Pag nandun ka sa middle, wala ka sa low, wala ka sa high. Okay? So let's have an example. Studies show that exercising can help prevent heart disease. Within reasonable limits, the more you exercise, the less risk you have of suffering from heart disease. Now, one way in which exercise reduces, ito yung kanina di ba? Okay. So, anong nangyari nga dito, yung example natin? Kanina we just checked if there is a relationship. Yung number of hours watching TV tsaka yung cholesterol level mo. So, if we're doing a regression, yung number of hours watching TV, that's now your independent variable. Tapos, napipredict mo ba yung cholesterol level mo? The cholesterol level then is the dependent variable. Okay. So, same example, except, kanina sa correlation, we just check on the relationship. Here, we check on what? On the cause and effect. Okay. Now, this is an example of a regression result. This is an example of a regression result. Okay, I'll do the interpretation, the simple regression result. Okay, look here. This is the variable, time TV, itong nasa loob, ito yung independent variable. Itong nasa taas, yung parang title niya, ito yung dependent variable. Now, I'll do an interpretation of the regression. Sinasabi niya dito that the regression coefficient is 0.04. So I say that for every 1 unit of increase in time TV, there is a 0.04 unit of increase in cholesterol level. That's the very simple interpretation of that. No, I repeat. No, for every 1 unit of increase, okay, in time TV, there is a 0.04 unit of increase in the cholesterol level. Okay, that's the variability, no, that is caused by time TV. So napipredict mo yung cholesterol level mo, no, that let's say for example, for every 1 hour, no, if that is the unit of measure, no, for every 1 hour that you watch TV, nararagdagan ng 0.04 yung cholesterol level mo sa katawan. Okay, now question, no, is time TV a significant predictor of cholesterol? Look here, the p-value is 0.0. If the p-value is less than 0.05, just like in this case, it is 0.0, then no, the regression is significant. So you say, no, the time TV is a significant predictor of cholesterol. Why? Because the p-value is 0. Okay? Now, there are other things, no, that you must know here, no? So, ito yung kanina, yung individual, no? Okay. Now, here, the number of observations, 100, no? This is very important, the F value, no? Okay. In parentheses, you have the degree of freedom. It's 1,98. No, it's actually a total of 99. No, this one, I'm not sure but why it's presented like this. No, 1,98, but you do it like this. But F, this is the predictive, no? This is the predictive power, no, of using time TV, no, to predict cholesterol. This is the overall predictive power. This is now the F value. Okay? Now, here, you have the p-value in the regression model. It's 0.0001. If this number is less than 0.05, therefore, the regression model is good. No, it is significant. Okay. Now, there's what we call the R-squared. No? The R-squared explains the variability in the dependent variable that is caused by the independent variable. So, tinitignan mo ha, like for example here, the variability is just 0.1513. So, kung gumagawa ka ng research, this is not acceptable. No? Kasi, ang ibig sabihin, there are other factors, there are other independent variables, no, that cause the increase or decrease in the cholesterol level because this is just very low. No, so kailangan mo ng other independent variables. Okay, this one is very low. Ang alam ko, ang kailangan mga 0.6 or 0.8, parang ganun. The higher, the better. That's why we're using multiple regression sa ating mga research papers. Kaya lang ito, this is just for the illustration. Kaya isang variable, independent variable pa lang ang ginagamit natin. Okay? Now, that R-squared is for the sample. The adjusted R-squared is for the total population. Anong gagamitin natin sa interpretation? It's the R-squared, not the adjusted R-squared. Okay? So, given that, let's have some more explanations. Okay. So, paano natin siyang i-interpret? Here. So, let's have the interpretation. It says here, a linear regression established that daily time spent watching TV could statistically significantly predict cholesterol concentration. Okay, what do you disclose? The F value, this is the overall predictive value, which is 17.47, but in parentheses, the degree of freedom. The P value, okay, because that determines, no, if if the regression is significant, that is P is equals to 0.0001, and time spent watching TV accounted for 14.3% of the explained variability in cholesterol concentration. What is this 14.3%? It is the this one, the R squared. No, I think it should be the R squared, not the adjusted R squared. I'll just change this one. No, okay. And then the regression equation was predicted cholesterol concentration is equals to, I'll explain this later. No, this is the regression equation kasi is equals to y is equals to a plus bx. Y is the dependent variable, a is the constant, and then the y is equals to a plus bx. Y is the dependent variable, a is the constant variable, and then bx represents the independent variable. So ito yun. So ito yung constant eh. Here, the constant here is 2.13. So ito yun. Y, that is the cholesterol concentration, is equals to A, this is 2.135, plus this is the independent variable. Now the regression coefficient multiplied by x1. X1 is time spent watching TV. Okay, now gawin natin yung sa atin, no, using HSB2. Okay, now how do we do it? Here. Kung nababasa nyo to, medyo maliit lang, no? Ito yung magiging command natin, regress. Okay. Then you have the dependent variable followed by the independent variable. That's how you execute a linear regression using Stata. I repeat, the command is regress. Okay, and then followed by the dependent variable followed by the independent variable. I repeat, regress dv iv. Okay, like in this case, sabi niya, regress college math, high school math. Ang ibig sabihin, nape-predict ba ng high school math yung score mo sa college math? Okay, let's do that here. Here. Ito. Palitan natin yung science, no? As in math muna. Palit muna ako ng mga variable names. Let's say math is, gawin natin high school math. Tapos si science naman, siya si college math. Example lang. Ayan. So my research is investigating the effects of high school math on college math. Ayan. High school math, college math. Okay. Okay, what's the command? Regress. Mauna yung DV. DV is college math, and then this is high school math. So here now is your regression. Ayan. So sinasabi niya dito that the regression coefficient is 0.67. Okay? So how do you interpret this? For every 1 unit of increase in high school math, there is a 0.67 unit of increase in college math. So nape-predict niya yung 67%, no, of your college math. Now, is it significant? Yes, because the p-value is 0. This is less than 0.05. I repeat, how do you read this? For every 1 unit of increase in high school math, there is a 0.67 unit of increase in college math. Okay, ito yung nag-survey ka na, di ba, sa research paper mo. Tapos nakapag-gather ka na ng data, pag pinaprocess mo na, nandun ka na ngayon sa chapter 3 or chapter 4, sasabihin mo na ngayon kung tumama yung mga hypothesis mo. Di ba? If the results no support your hypothesis. Ito na yon. No, like for example, no, if hypothesis number 1 is high school math significantly affects college math, then if this is your result, therefore, hypothesis 1 is supported. Why? Because P is less than 0.05. Now, what is the overall predictive value? It's 130.81. The p-value is 0 here. This is for the overall regression model. And then the r squared is 0.40. Okay? Now, let's do it here. Let's say ito yung result niya. No? So, here is the interpretation. Okay. Ayan, college math at saka high school math. Oh, we have the same numbers. Here's how you do it. First, you interpret the overall regression model. So sinasabi niya, significant ba? Okay ba yung regression model natin? Ito here, sinasabi niya, yes. Sabi niya, a simple regression was run to predict college math from high school math. High school math statistically significantly predicted college math. When do I say that? If the p-value here is less than 0.05. In this case, it is 0. So you can write p is equals to 0 or p is less than 0.05. And then the r squared, that explains the variability of the dependent variable caused by the independent variable or variables. It's 0.3978. And then let's have the individual interpretation. So sinasabi natin, for every 1 unit of increase in high school math, there is a 0.67 unit increase in college math. P is equals to 0 or P is less than 0.05. Now, why am I presenting the overall regression model and then this one, the independent, the individual interpretation? Why do I have to present that? Because there are cases, let us say, for example, you have 3 or 4 independent variables. Overall, they help each other. Pag pinagsama-sama mo sila, magiging significant yung regression model. Pero individually, hindi sila significant. Baka yung 3 o yung 2 lang ang magiging significant. So we have to show this one, the interpretation for this, for the overall regression model. Okay, let's have another example. O ito naman. Sabi natin kanina that the independent variable can be a continuous or a categorical variable. Okay, let's have another example. Okay, so our next example is we want to predict if gender can determine or predict our college math. So that's an example of an independent variable that is a categorical variable and a dependent variable that is a continuous variable. Okay, so in that case, I'll share now my Stata. Okay. Guys, di ba kanina female? Okay, if you're using regression, at gagamitin ko ito, si gender, for my regression, mag-assign ka ng numbers, like in this case. Ayan. Di ba si female 1 siya? Si male 0. I remember I demonstrated this last time, So the higher number follows, or the higher number or the label of the higher number becomes the title or the heading. Like in this case, I repeat, I assign 0 to male and 1 to female, which is the higher number. The higher number is female. Okay? Now, let me change the title or the heading to female. Okay, so there. So I have here female already. Now I'll do the regression. Now regress. Okay, what's my framework? Ano yung hypothesis na gagamitin ko? That gender significantly affects my college math. So my college math is my dependent variable, and then gender name is female. Let's see what happens here. So this is now the result, no? Female or gender, and then college math. Female is the independent variable. The dependent variable is college math. Okay. Now, what's the regression coefficient? No, it's a -2. Now, how will you interpret this? Females, mauuna, no, yung heading. Females versus males would have a college math score lower by 2.53. I repeat, no? If this is negative, you say lower. If it is positive, higher. So it says females versus males would have a college math score, okay, lower by 2.53. Question, no? Is gender a predictor of college math? Oh, look at the p-value. The p-value is 0.07. It's higher than 0.05. So is it a predictor? No, gender, is it a predictor of college math? No. No, because this number must be less than 0.05. So gender is not a predictor of your college math score. And it makes sense. Even the literature supports that. No, the gender is not a predictor of your college math. Okay, let's have that interpretation. Here. O ito. So first, let's describe the overall regression model. It says here, a simple regression was run to predict college math from gender. Okay, and what's the p-value here? The p-value here is 0.07. So it says, gender did not statistically significantly predict college math. Okay, and then you have this numbers. And then the one that I told you just a while ago, females compared to males, or female students compared to male students would have a college math score lower by 2.53. P is equals 2.071, or P is greater than 0.05. Okay, so hindi siya predictor, no, si gender. Okay, now lastly, no, I will do a multiple regression. Okay, in a multiple regression, okay, we say that there is what? One dependent variable and two or more independent variables. Like in this case, sabi niya, regress, science, read, write, female. Okay, so yung science, yun yung college math kanina, di ba? Okay, ibalik na natin. Okay, so palitan na natin si ano. O anyway, okay lang naman yung college math, no? Ano yung predictors natin? Read, write, gender, no? Okay, let's do that. Regress, college math. Okay, what are the dependent variables? Read, write, gender, or female. Oh, let's do that. This is now a multiple regression. Okay, so ito yun. Look, let's look first at the overall regression model. What's the p-value? No, the p-value is 0.0. So this is significant. No? Okay, and what's the r-squared? Look at the r-squared. The more variables, independent variables that you have, tumaas yung r-squared natin. Kanina nandun lang siya sa 0.1 eh. Now it's 0.49. So this 0.49 explains the variability of the dependent variable caused by read, write, and gender. Okay, and the overall predictive value is 63.69. Okay, now let's look here. Individually, let us interpret. No? Sabi natin, it is significant. Okay? Tignan natin, if individually, no, magiging predictor sila ng college math. Okay, here, read. For every 1 unit of increase in reading score, there is a 0.37 unit of increase in college math score. P is equals to 0. So significant. So reading is a predictor of college math. Next. For every 1 unit of increase in writing score, there is a 0.41 unit of increase in college math. P is equals to 0. So significant. O here, females versus males would have a college math score lower than 4.14. Is it significant? Yes. Naging significant na siya ngayon dito. No? Together with other variables. Okay? So let's have the interpretation of that here. Ayan.
Sir, wala po maka-plus na ano sa screen.
Ngayon, ano yung naka-flash ngayon?
Wala po, sir. Nag-screen sharing pa lang po.
Here.
Yes po, sir. Loading po lang po, sir.
Ah, sorry. Okay. Yan. Ano yung naka-flash?
Loading pa rin po, sir.
Okay.
Loading po, sir.
Check lang natin, ha. I don't know. Yung sa akin ba yung ano, mahina? Ito, I'm sharing again, ha. Yan. What do you see?
Wala pa rin po, sir.
Wala pa rin.
Umiikot.
Strong pa yan. Anyway, no, I'll just anyway, I will send this sa lahat sa inyo. Okay. Kailangan makita mo. Yan, nakikita na ba?
Wala pa rin po, sir.
Bakit kaya?
Wala pa rin po, sir. Kaya po umiikot. Umiikot po yun, sir.
Yan. Let's check natin. I think something is wrong. Ah, okay. Your screen sharing is paused. So, paano to? Yan.
Baka po mahina yung net nyo, sir.
Sandali, ha. Gawin natin ang paraan.
Okay. Ikot-ikot lang. Ikot-ikot.
Sandali. Ito nakikita na. Yan.
Hindi pa po.
Wala pa rin? Bakit?
Opo,
Wala pa rin po.
Tingnan natin pa. Sobrang dami kasi nakabukas. I'll try again, ha. Yan. Wala pa rin?
Wala pa rin po.
You are screen sharing. Anyway, hindi siya pwedeng stop kasi. Anyway, guys, I'll just read it, ha. Okay. since I mentioned that this is now an example, no, of a multiple regression, why do we call it a multiple regression? Because we have here one dependent variable, which is what? Which is the college mass, and then we have two or more independent variables. What are they? The reading, the writing, and then the gender. Okay, so first, no, I will interpret the whole, no, the overall regression model. No, so let me just read it. No, just listen, but I'll give you a copy of this. A multiple regression was run to predict college math from reading score, writing score, and gender. No, and since the p-value is 0, so I say that these variables is statistically significantly predicted college math. Okay, and then I'll do my I'll write my numbers. No, the F value, the overall predictive value is 63.69. Okay, the P value is less than 0.05. And then the R squared, this one explains the variability of the dependent variable caused by the independent variables. It's a higher number now, it's 0.4936. Okay, now individually, no, significant ba? Let's find out. It says here that for every 1 unit of increase in reading score, there is a 0.37 unit of increase in college math. P is equals to 0. Another one. For every 1 unit of increase in writing score, there is a 0.41 unit of increase in science score. P is equals to 0. And then lastly, to interpret the categorical binary variable, females compared to males would have a lower college math score by 4.14. P is equals to 0. Hindi siya masyadong ano kasi hindi nakikita. Okay, so